Hi everyone, my name is Heather Davidson. I'm the lead naturalist at the Environmental Nature Center here in Newport Beach. Thank you so much for tuning in today. Just before we get started, I wanted to shout out our other really great live events that are happening. We have one with our other lead naturalist, Raquel, on Friday here at 1 o'clock, and then a whole bunch throughout the rest of the month and the beginning of May. So go ahead and go on our website, check out our calendar. We have a lot of really cool live events that are going to be posted. Today, we're going to be taking a deeper look at some of our animal ambassadors that are native here to Southern California. And our very first friend we're going to meet, she's a little bit scary to some people sometimes, but don't be afraid. She's really, really nice. We're going to take her out. This is my friend Charlotte. She is a Chilean rose-haired tarantula, and she's obviously not native to here to Southern California, but she is related to the blonde tarantula that you could see hiking out here in Southern California. Now, one thing about her is that she is an arachnid, so she's in the animal kingdom as an insect, or not an insect, sorry. She's an arachnid underneath the animal family arthropod, and arthropod means jointed legs. So these are animals with all these sorts of joints. Their legs bend at different places. Go ahead and take a minute, think about some other examples of arthropods, maybe arthropods that live in the ocean, maybe they live in your backyard. So she has 8 legs, and that's one of the defining characteristics of an arachnid that makes her different than grasshoppers or ladybugs. So those animals have 6 legs, she has 8. Let's go ahead and count them all together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Something happened. I counted 10 legs. If you're thinking that these two in the front of her body are a little bit different, I agree with you. Those aren't legs. Those are one of my very favorite scientific words in the whole world. Those are called pedipalps. And those pedipalps help her to see the world around. Her eyes are on the top of her head here, so if she's approaching the edge of a cliff or the edge of my hand like she is right here, her pedipalps tell her to stop walking. If you do, you might fall off, so they help her to see around. Now, a lot of people are afraid of tarantulas, and I was afraid of tarantulas at first too when I first got this job. So I did a little bit of research, and it turns out nobody has ever died from a tarantula. Nobody's ever been bitten, or no one ever has been bitten and died of a tarantula sting. Their bite is less harmful than a bee sting. It's no big deal at all. So she's never killed anyone. The reason why a lot of people are afraid of her is because of Hollywood. So scary movies, Halloween, make these creatures seem scarier than they actually are. They're actually really, really nice and gentle friends. One thing also, if she did want to try to bite me, she'd give me a few warning signs. One thing being that she would lift her whole body up. So she has to actually lift her entire body up in order to swing those fangs out, and then she'd be able to bite me, but not here like this. So I'm gonna go ahead and put her away. I'm gonna say, bye, Charlotte. We'll see you later. Our next animal that we're going to meet today is an amphibian, and he lives... Is there any questions before we get going? go ahead and put it in our comments below if you have any questions. Okay, so our next animal that we're going to be meeting today is an amphibian. An amphibian is a creature who can live both inland, on the land, and in the water. So our amphibian friend here is Elliott, the tiger salamander. He's called a tiger salamander because of all those stripes that you can see on his body. And Elliott is actually an endangered species. So you can find tiger salamanders out in Southern California, but they're kind of rare to come by. They're an endangered species because of habitat loss. So he lives in riparian ecosystems, close to streams and rivers where the water is nice and muddy. And people are building buildings over those riparian ecosystems, and then also pollution gets into these riparian ecosystems, and he's really affected by pollution. He's called an indicator species, which means that he indicates whether the habitat is healthy or not. So let's say he was in a pond with his cousins and somebody let pollution get into that pond. The amphibians actually drink water by absorbing it directly into their skin. So if there is pollution, they're also absorbing that pollution right away, right into their bloodstream, and it can make them sick. So scientists will look at the population of amphibians in different riparian communities, and if there's a lot of amphibians, then they can make the assumption that the habitat is relatively healthy. And if there's not a lot of amphibians, there's something that they need to do. There must be something wrong with the water. They need to help that water quality before the other animals in the ecosystem, like birds and bobcats, coyotes, might start getting sick. Now, Elliott has a very cool adaptation. He is a poisonous animal. Now, no big deal. It's okay that I'm holding him. Poison is when you ingest something and it makes you sick. So he, if I was to eat him, could make me sick for a number of different reasons. But he has very cool colors on the underside of his body, a bright yellow. Those are warning colors. So some animals have warning colors that tell predators, hey, watch out, don't eat me, I'm not good to eat, I'm going to make you sick. And those really bright colors help him to do that. So you think of any other amphibians or any other animals that have really bright colors that say, hey, watch out. If you're thinking things like poison dart frogs, those are really great examples of animals who are saying, hey, I'm poisonous, you better leave me alone. You might be wondering what Elliott likes to eat. He is an omnivore, so he'll eat anything that he can come across, mostly plants and small insects, mealworms, things like that that he can find crawling around on the forest floor. He is a very interesting guy. What sorts of animals do you think might eat Elliott? You think anybody might try to eat him? Very cool. All right, I'm gonna put Elliott away. Everyone say goodbye, Elliott. See you later. We're gonna move on to our next animal friend, who is part of my favorite group of animals. These are animals with scales, who are cold-blooded creatures, and they might also be seen as scary, but I hope that at the end of this you won't be afraid of them anymore. This is my friend Fernanda. She is a California king snake. She's native here to Southern California. If you were out hiking around, you might be able to see a snake very, very similar to Fernanda. Now it's a little bit cold today, so she's holding on to me and making herself into a pretzel in my hand. She is a cold-blooded animal, but that doesn't mean that she has cold blood. What it means is that her body temperature actually changes with the outside weather. So if it is 60 degrees outside, her body temperature is 60 degrees. She's cold, she's a little bit slow. If it's 100 degrees outside, her body temperature is 100 degrees, and she can move really, really fast. So make a prediction. Do you think that reptiles would rather be cold, or would they rather be warm? What do you think? If you're thinking warm, I agree with you. The reptiles love to be warm. It helps to help them be fast to escape from predators. So maybe eagles flying high in the sky might try to come down and grab her. And also it helps her to catch her own prey. So she would eat things like mice, scurrying around on the ground, and she needs to be really fast in order to catch those animals. So being warm certainly helps them. And that's the reason why you might see snakes on the road, on the pavement or sidewalk, or lizards sunning themselves on rocks and on fences. They're trying to absorb as much of the sun's rays as possible to bring that body temperature up so they can move really, really fast. Now, Fernanda is related to other king snakes, and another kind of king snake that you might see out in the wild are the king snakes that are red, black, and yellow. And those snakes are trying to mimic a coral snake's color pattern. So coral snakes are venomous snakes. King snakes are not venomous. No venom inside them. They're constrictors. They squeeze their prey. And those red, yellow, and black signs, just like Elliott, are warning colors saying, hey, watch out, I'm dangerous, you better leave me alone. So coral snakes are venomous, but a bird who's high in the sky might not know how to tell the difference between a king snake and a coral snake. So that red, black, and yellow, they see that, they say, hey, I'm leaving that alone, I'm not taking my chance that I might get a coral snake. There is a way that humans can remember to tell the difference between king snakes and coral snakes, and that's a little rhyme that you might be familiar with. Red on black, friend to Jack. Red on yellow, kill a fellow. So if those red stripes and the black stripes are touching each other, you know that it is a king snake. It's, I wouldn't say safe to be around. We want to leave all wild snakes alone, but it's certainly not a venomous creature like the coral snake. Now, she doesn't have venom inside her. She constricts her prey, and we used to think that she was constricting to squeeze the breath out of their prey, but that's actually not true. What they're doing is they're putting a lot of pressure on the chest cavity of their prey. So they're stopping the heart from pumping blood. They're giving their prey a little heart attack, and it kills them faster than dying of no air, which is kind of a cool thing. Now, what is she doing with that tongue? Can you see her tongue? Is she sticking it out? Is she being rude with that tongue? She is smelling with her tongue. She has an organ on the inside of her mouth called a Jacobson organ. So her nostrils here on the outside of her face don't bring air in and out to smell. That's how she breathes, but her tongue will get the little scent particles on it, and then she sticks her tongue up her nose inside of her mouth, and that's how she smells where her food is. And she has a forked tongue. Why do you think she has a forked tongue? If there was a mouse on this side of the room and a jelly donut on this side of the room, her tongue tells her exactly which direction she needs to move in order to get her food. Are there any questions so far? Okay. Well, before I put her away, I do want to say that king snakes eat rattlesnakes. That's one really cool adaptation that they have, and it's a very beneficial adaptation to us as humans because I don't know about you, but I don't want a rattlesnake in my backyard. King snakes are immune to rattlesnake venom, so if a rattlesnake bit her, no big deal. She would just squeeze and constrict that rattlesnake in order to eat it. So king snakes actually help to protect your yard from rattlesnakes. They keep the rattlesnakes away, and your family and your pets can be out and enjoy nature safely thanks to king snakes. So that is really, really special. Okay, I am going to put her away. I'm going to say goodbye, Fernanda. The last creature we're going to talk about today, I don't have a live creature, but I do have some body parts that we can look at. We at the Environmental Nature Center like to teach with what we call biofacts in order to help bring things closer to you inside of the classroom or you here today. So we're gonna look a little bit closer at my friend, an owl, which we may not always get the opportunity to be very close up to owls. Now, owls are considered a bird of prey, and what makes them a little bit different than other birds are 3 adaptations. We have our sharp hooked bill for tearing meat off of the bone, sharp talons for grabbing and holding on, and then eyesight. You can't beat these eyes. These are super, super strong eyes. They're able to see mice down on the ground while they're soaring high in the sky. So those are 3 adaptations that birds of prey have that make them different than chickens or doves. But birds in general have one adaptation that make them completely different than all other animals. So you take a minute, think, what is on this bird, or what does this bird have that would set it apart? No other animal has that adaptation. If you said sharp beak or beaks, I might agree with you. They do have really sharp beaks, but there are other animals in the world that have beaks. Animals like squids and turtles have beaks for biting and tearing things open. So beak is not what would set it apart. If you're thinking wings, I say that you're almost there. You're on the right track. Other animals do have wings, like flying squirrels or bats for flying high in the sky. So not wings, but take a closer look at those wings. What is on the wing? Feathers, right? Do any other animals have feathers in the world? Not alive, not right now. Scientists recently discovered that dinosaurs actually may have had feathers, or did have feathers, which is an incredible finding. So our birds are the closest living relative to dinosaurs, not lizards, which is a really cool fact. So feathers is the one adaptation that sets birds apart from other creatures. No other living animals on Earth have feathers, which is very, very special and unique. And those feathers serve all sorts of different purposes. Helps the animal to fly, helps it to blend in, camouflage inside of its ecosystem, and it can also help it in a very special way. So owls actually have, can you see closer on these little feathers? They're kind of wispy, and they almost look as if somebody kind of spread the little feathers apart. They're not nicely put together, and that helps the owl stay really stealthy and quiet. So the air is actually able to travel through the little ends of the feathers, so you can't hear the bird flapping in the sky, unlike if you were to use a wing. This is a wing of a hawk, and you can hear the bird flying through the air if I'm flapping the wings like this. Let's see if you can take a minute to listen. know, hopefully it picks up. So you can hear this hawk flying in the sky. They are awake during the day, right? So hawks don't need to worry about being quiet. Their prey can see them on the ground. Doesn't matter that they're loud. They have speed on their side to catch their prey. Owls need to be quiet, so they have slightly different feathers, kind of wispy, soft feathers, so that you can't hear when they're coming at night, which is really, really cool. Another thing about owls is they have feathers all the way down to their toes. So I have a hawk's foot right here for comparison. You can see the scales on the hawk's foot come all the way down to their toes. Their leg is completely exposed. The feathers come all the way down on the owl's feet. I want you to take a minute and think, why did the owls have feathery feet and hawks don't? What do you think? If you think it's to stay quiet, I agree with you. Once again, these feathers on the feet help to silence the animal, help it to be a little bit quieter. Imagine you were running through your house and you had a pair of sneakers on. It would sound really, really loud. But if you were running through the house and you had a pair of slippers on, a little bit quiet, right? A little quieter than those sneakers. So the feathers on the feet help the bird be really, really quiet when it's hunting. Thank you so much for joining us today. If you had fun, I encourage you to tune back in Friday at 1. Raquel is going to talk to us more about bird beaks and the different specialized beaks to help those different birds live in different habitats or to eat different things, which is going to be really, really fun. I'm excited to watch that one. If you have any other questions, I'll be around on Facebook for a little bit to answer those questions on this thread. Put them in the comments below. Thank you so much for tuning in. Bye.